In this video, I am going to solve this differential equation. By looking at this differential equation, it looks like that it is an exact differential equation which has the format. Let's use a different color. Which is the format p of x comma y dx plus q of x comma y dy is equal to 0. Here p of x comma y is cosine of y, q of x comma y is y square minus x sine of y. Now, to ensure that this is actually an exact differential equation, we need to make sure that del p over del y is actually equal to del q over del x. And let's find these partial derivatives. Del p over del y is equal to del over del y cosine of y, right? So derivative of cosine of y is negative sine of y. Similarly, del q over del x is going to be del of del x y square minus x sine of y, right? Which is actually just negative sine of y, because derivative of y square with respect to x is 0 and derivative of x with respect to x is 1, so that leaves me with sine of y. Now that shows me that both of these partial derivatives are equal. In essence, this is equal to that. Del p over del y is equal to del q over del x. So this differential equation is an exact differential equation. Now we can easily find the solution to this. That's not hard. We know that p of xy, right? P of xy, x comma y, is actually the solution to that potential function or the function that we are looking for, which is going to be solution to this differential equation. So let's call it f of xy. So it's going to be del f over del x. Okay, and the answer format, or the solution format rather, is going to be f of x comma y is equal to some constant. So this is going to be the solution format. Now, p of xy, we know it, which is cosine of y. So in essence, del f over del x is equal to cosine of y. Now, if I integrate this with respect to x, integrate this with respect to x, what do I get? This is going to yield f of x comma y. And integral of cosine of y with respect to x is going to be nothing but x cosine of y, right? Then we need to add a constant function, a function of y. Let's call it g of y, which kind of serve as a constant because we are integrating with respect to x. So this is a function of y. Now, in theory, we have a solution, right? F of xy. However, we still do not know what is g of xy. Can we find it? The answer is yes, we can go ahead and find it. How do I find it? See, we have f of xy. We know that del f over del y is nothing but q of x comma y. And q of x comma y is just equal to y square minus x sine of y, which is just this. However, what is del f over del y? I have f, so if I take derivative of it with respect to y is going to be negative x sine of y, because derivative of cosine of y is negative sine of y, plus derivative of g, which is g prime of y, that's going to be equal to y square minus x sine of y. Now I could add x sine of y to both sides to cancel it out, plus x sine of y. That's going to give me g prime of y is equal to y square. Now if I integrate both sides, g prime of y dy with respect to y is going to be integral y square dy. So integral g prime of y dy is nothing but g of y, and that is going to be equal to integral of y squared dy, which is going to be y cubed over 3. Now I can take this g of y and plug it into right here. Okay, so that's going to give me f of x comma y is equal to x cosine of y plus y cube, g of y is going to be y cube over 3. Now this, by the way, is the function that we have been looking for, and our general solution is going to be this is equal to some constant. So this is the solution to the exact differential equation that we are trying to solve. I hope that this discussion was helpful. Thank you so very much.